Okay, this is review that's marked as number 3, but it's the second one that we're doing in class. I went ahead and wrote the answers for the first 3. I think by now most of you know how to put this in your calculator. But just as a reminder on number 3, the 9, because 5 is greater than 9, bumps to a 10. So that makes a 0, 1. So it's 0.710 if you round it correctly to 3 decimal places. We're really working hard on rounding it correctly. Okay, the next 3, we need to write our equation and an answer. You will not get full credit on your test if you just give me an answer because I need to know how you got the answer. All right, so when I rewrite this, I'd rewrite as log base e, which we don't write. So we'll write the natural log of 94 equals 3x. And then to solve, we're going to divide by 3. So now, and if you write all that, I'm good to go for your test. So now let's put that into our calculator. So we're going to have the natural log of 94. You've got to close that parentheses and then divide by 3. We get 1.514. And there's our answer. Let's try this again on number 2. On number 2, I'm going to rewrite it as log base 3 of 152 equals x plus 7. So to solve, I'm going to subtract 7 from both sides, and then I can get my answer. So let's see how that goes into my calculator. So to get a base of something other than the invisible 10, I have to go to my math menu, up to option A. So I have log base 3 of 152, arrow out of the parentheses, minus 7. You got to make sure you arrow out. And then we get negative 2.427. All right, one more. This one, I'm going to rewrite it. It's going to be log base 8 of 82 equals x minus 3. So to solve, I'm going to add 3 to both sides. And now I'm going to go put this in my calculator. Clear that out. There's a lot in there. Okay, go to the math menu, up to option A, log base 8 of 82, arrow out of the parentheses, plus 3, and then hit enter, and we get 5.119. Now, these first 6 problems would all appear on the calculator section of your test. Your test review is pretty well labeled, but just want to mention that as we're going through here. Okay, this section, expand each logarithm. This is going to be no calculator because there's really no calculations on this. But remember that on the test, I'm going to let you use your power sheet on the no calculator part, which should be a really big help for some of you. All right, so because this is division, I'm going to rewrite it with subtraction. So I'm going to have log x to the 8 minus log y to the 7. And then I'm not quite done because I got to move those exponents out front. So I have 8 log of x, or 8 log x, and then 7 log y. And that's my final answer. Okay, number 8, I'm going to split it also with subtraction, but I know that I can rewrite this one. 25, pretty much everyone knows, is 5 squared. 32, you may not remember. So if I look at my powers list, the only place I have 32 is down here at the bottom with 2 to the 5th. Okay, that's the wrong one. My bad. So I can rewrite this as 2 to the 5th. So when I rewrite it, I'm going to have log 5 squared minus, because whatever's on top goes first, whatever on the bottom goes second, log 2 to the 5th. And then I'm going to move my exponents to log 5 minus 5 log 2. Okay, natural log, still same thing, but because it's multiplication, I'm going to split it with addition. So it's going to be the natural log of x to the 5th plus the natural log of y to the 8th. Move the exponent in front. So I have 5 natural log x plus 8 natural log y. On the next part, now we're condensing it. Well, these do not have a base. So if it doesn't have a base, if there's invisible base 10, well, there's no way I can write 8 and 7 with a base in 10. So I'm just going to work the problem out. And because it's addition, I'm going to rewrite it as multiplication. So I have log of 8 times 7. I can simplify that, so I should. So I'm going to get log of 56. And there's my answer. Okay, number 11, since we're going backwards, when we expand them, exponents are last. So when we shrink them and condense them, the exponents have to go first. So we're going to move the exponents back. So I have the natural log of a to the 4th minus the natural log of b to the 6th. And now because it's subtraction, I can make it division. So I have the natural log of a to the 4th over b to the 6th. Number 12. First things first, got to move the exponents. So I have log base 4, x to the 7th, plus log base 4, y to the 3rd. Remember, it doesn't matter if it's a log 4, a log, a natural log. You're not changing any of that part. You're just dealing with the variables and the numbers. And I know 4 is a number, but it's the base of a log, and we don't change that. So now, because it's addition, I'm going to rewrite it as multiplication. So I've got log base 4 of x to the 7th, y to the 3rd. All right, one last one in this section. We got a lot going on here, but we can make it work. So first move the exponents. So we have log base 8 x squared plus log base 8 w to the 7th plus log base 8 z cubed. Just kidding, this isn't a plus, this is a minus. Okay, the first two are plus, so that means it's multiplied. Last one is minus, so that means it's divided. So we're going to have log base 8 x squared w to the 7th over z to the 3rd. And there is our answer. Okay, number 14, we're going to use the log properties now to simplify and evaluate. So on number 14, we're going to look. There's no way that we can make this a base 10. So we're going to combine it together. And I'm going to have log base 7. Because it's minus, I'm going to combine it with division, 84 over 12. We always want to simplify. So this is going to be log base 7. 84 divided by 12 is 7. And if I have the same base and same number here, my answer is always 1. Okay, number 15. We want to see if we can combine it, but because we're going to look at this base, and that's a 2. So that's saying if you can, write everything as a base of 2. So I'm going to have log base 2. 8 I can rewrite as 2 to the 3rd. And again, I'm just using my powers chart. Plus this one I can rewrite as 2 to the 5th. Well, because it's plus, I can combine it as multiplication. So I'm going to have log base 2 of 2 to the 3rd times 2 to the 5th. And now I'm going to ignore the log for a second and just focus inside the parentheses. I have the same base, so I can add the exponents. So I'm going to have log base 2, and this is going to be times 2. The 3 plus 5 is 8. Anytime I have an exponent, I can move it to the front. So it's going to be 8 times log base 2 of 2. Well, log base 2 of 2 is 1, so this is 8 times 1, which is just 8. Okay, number 16, I want you to change it to a plus sign because it was a minus. Okay, so right here in the middle, change that to a plus instead of a minus. All right, well, if I'm looking at it, it's got a base of 5, but I can't rewrite that. I can't rewrite 4 or 100 with a base of 5, so I'm just going to combine them. And because it's plus, I'm going to combine it with multiplication. And if I have 4 times 100, when I multiply that, I get 4 over 100. So I'm going to have log base 5 of 4 over 100. Well, we always reduce. So that's log base 5 of 1 over 25. Well, the good news is we can convert 25 to an exponent or a power. So I'm going to do log base 5, and I have 1 over 5 squared. Okay, well, this doesn't quite work, but it's close. Okay, we moved them to the denominator if it was negative. So if I want to move it back up, I can just make it negative. We used to want to make them positive, but now it's okay if it's negative. So can I rewrite this as this? And now I can move the negative 2 out front. So I have negative 2 times log base 5 of 5. So I have negative 2 times 1, which is just negative 2. All right, last one. We want to rewrite this, or we want to solve for x, and we don't need to use logs. Okay, so on this one, we want to find them to have the same base so we can set the exponents equal to each other. Well, if I look at my power sheet, 64 could be 8 squared. 64 could be 4 cubed. And that's about it. It's also 2 to the 6, but that's not on my sheet. Okay, 16 could be 4 squared. Oh, look, 4 squared and 4 cubed. There's a match. They're both 4s. That's the one that I want to use. So I'm going to rewrite 64 as 4 cubed x plus 3. And this one I'm going to rewrite as 4 squared 2x minus 5. Now that I've rewritten them with matching bases, I can ignore the bases and just set the exponents equal to each other. So I have 3 times x plus 3 equals 2 times 2x minus 5. So I'm going to distribute, and I get 3x plus 9 equals 4x minus 10. Now we can easily solve. I'm going to subtract 3x from both sides and add 10 to both sides. And that leaves me with 19 equals x. And we're done.